right, graphing one more time with this, ladies and gentlemen. Let's get into it. Now, these ones are going to be in the form y equals ab to the x, where b is the factor that determines whether it's an exponential growth or exponential decay. Now, the first two here are exponential growth because we have a 2 and a 3 in that slot. So I'm going to pick one, and then we're going to go for it. All right, so number 2. I'm going to start off by going real slow. So if I'm plugging in -2 right now, this is 2 times 3 to the -2nd power. So exponents have to go first. So this 2 is going to be staying out here, hanging out while things happen to this 3. Because 3 to the -2nd power is 1 over 3 to the second. And then 1/3 squared is going to be 1/9. Now, what is 2 times 1/9? It is 2/9. So I'm going to write that over here. Come on. There we go. So 1 down, 4 to go. Now, it's okay for some of these to look a little weird, by the way. We just have to make sure we're doing our best. All right, now I'm going to go ahead and try and, like a surgeon, take away what I don't want. All right, so now if I'm plugging in -1, all right, the negative flips it into 1/3. And then if I have 2 times 1/3, that's just going to be 2/3. So we're getting a little closer to numbers that we can graph, which is great. Now, let's say I have 3 to the 0 power. Dun, dun, dun. Well, 3 to the 0 power is 1. So then 2 times 1 is 2. We can graph that one. That one's not bad. All right. What about if I had 3 to the 1st power? Well, that'd be 3. So 2 times 3 is 6. We can graph that as well. What if I had 3 squared? Well, 3 squared is 9. 2 times 9 is going to be 18. Janky looking 18, but that's all right. Still 18. I like to think when I was 18, I was a janky looking 18-year-old as well. So here we go. -2, 2/9. So it's so far down there, but not 0. Not there yet. -1, 2/3. A little higher, more than a half. 0, 2. Goes right there. 1, 6. Awesome. And then 2, 18. And so this is, as previously mentioned, exponential growth. We're going to do our best to connect these dots. I missed that one, but that's all right. That's kind of what it looks like. Now, the crazy thing about both of these is that they have a negative out in front, which means no matter what happens, every answer is going to be negative. So if you look at our graph is only below the x-axis, which tells us that we're going to be dealing with a whole lot of negatives here. So let me go ahead and show you exactly what's happening. We have -5 times 2, and if I plug in -2nd, that's like -5 times 1 over 2 to the 2nd power. So -5 times 1/4, which would be -5/4. Okay? Okay. So that's how we're going to start this. All right? And it's going to be okay. Then, if I take it to the -1st power, instead of the -2nd, this would be 1 over 2. And 5 times 1/2 is going to be -5 over 2, which is the same thing as -2.5. That might be easier to graph. That's why I did that. All right. Now, if I change that up, what if I took 2 to the 0 power? Well, that would be 1. -5 times 1 is -5. You can graph that one rather easily. Boom, working ahead. Then, if I had 2, not -2, 2 to the 1st power, well, that would be 2. -5 times 2 is -10. Got that one. And then I have 2 to plug in. So this will be -5 times 2 to the 2nd power. 2 to the 2nd power is 4. -5 times 4 is -20. So all the y values are negative here, which makes sense because when there wasn't a negative, all the y values were positive. So if I plot these, -2, -5/4, that'd be -1.25. Then -2.5 goes right here. And there's my 0, -5. Love it. Then I have 1, negative 10. Brilliant. And then I have 2, negative 20, which just barely fits. All right, now, I could put in some other points. It's going to look like this. Okay, and there's that. Now, keep in mind, that was 2. It's bigger than 1. It should be exponential growth, but because this is negative, that's what inverted it. It flipped it down. It's going down now. All right, over here, for number 4, let me change the color so you can tell the difference between these two. I have negative 1/4, which is a gross fraction, but we're okay with it. And then times 2, and I'm going to start by putting to the negative second power. This would be negative 1/4 times, this would be 1 over 2 to the second power. So negative 1/4 times 1/4, so it would be negative 1/16, because 4 times 4 is 16. All right. Then if I try to the negative first power, that'd be times 1/2 to the first, so times 1/2 is going to be negative 1/8. If we try to the 0 power, all right, now it's getting easier. After those first two fractions, now we should be good. That's going to be 1. Negative 1/4 times 1 is negative 1/4. More fractions, bummer. Then we're going to try to the first power. So negative 1/4 times 2 is going to be negative 2/4, which is negative 1/2. And then finally, we're left with a better number, because when we square 2, we get 4. Negative 1/4 times 4 is going to be negative 1. There's a good point. And hopefully you're seeing, oh, well, what if we try some better numbers? So when I say better, I mean like 3 and 4. Let's see what happens with those. Let's add those to our list, because it's going to make it better. We always want to make things better. So I have negative 1/4, and this is times. Let's plug in 3. 2 to the third power is 8. Negative 1/4 times 8 is going to be negative 8 over 4, which is negative 2. That's a good number to plot. What if I tried putting in 4? I wonder. 2 to the 4th power is 16. So this would be negative 16 over 4, which would be negative 4. Now we have some way better numbers to graph. Way better points, if you will. So negative 2, negative 1/16. Somewhere down there. Then it's there, and then 0, negative 1/4. So still, we're scraping the bottom here, real close. Things start to get better at 1, but not really. And then we get 2, negative 1. There's a good point. 3, negative 2 is another good point. 4, negative 4 is another good point. I could keep going if I wanted to. Let's say I plugged in 5. The last one here. If I plugged in 5, the y value you get would be negative 1/4 times 32. 32 divided by 4 is 8, so this would be negative 8. All right, so negative 8, go right there. And those are all the points that I really want to see on your graph. You're responsible for copying that whole chart down, especially the ones where I had fun with, okay? Excuse me. I want to make sure that got on the video. All right, so skipping down to number 4. This is going to be exponential decay because we have a 1/2 right in there. So look out. Here we go. This will be 4 times 1/2 to the negative second power when we plug in negative 2. So this will be 4 times 1/2. No, it's not. It's going to be 4 times 2 over 1, because when you flip it, and this would be 4 times, well, 2 squared is 4. 4 times 4 is 16. All right, way better than a lot of those answers we got in the last problem. Now, if I plug in negative 1, this would be the same thing as 2 over 1 to the 1. Well, 4 times 2 is just 8, which is great. Then we have 0. Well, 1/2 to the 0 power is 1. 4 times 1 is 4. Then we change it up a little bit. And now it's getting even more fun, because when we plug it to the first power, we have 4 times 1/2. Well, 4 times 1/2 is 4 over 2, which is a 2. Then maybe our last point here, unless it's not as good as I think it is. 1/2 squared is 1/4. 4 times 1/4 is 4 over 4, which is 1. So negative 2/16, right there. Negative 1/8, right there. 0/4, right there. And I have 1/2, right there. And 2/1, right there. If I wanted to keep going, I could. I'd plug in 3, and if I plugged in 3, this would be 1/8, and then this would be 4/8, which would be 1/2. So if you plug in 3, you get 1/2. If you want that extra point, go ahead and put that on there. Either way, it's not bad to have more good points. Still, that asymptote being the x-axis, not going to cross it. Okay, last problem. We're going to get on number 7 over here, okay? And it's going to look similar to number 5 once you've done that, but for here, it's just different. So it's going to be reflected over the x-axis, so it'll be inverted. But you don't have to tell or to know that right now. So here we go. -2 times 1/2, and we're first taking it to the -2nd power, which means this is -2 times 2 to the 2nd power, 2/1. You flip it. So this would be -2 times 4, which is -8. All right. You doctor this up a little bit. Now if I take it to the -1st power, this would be like 1/2. So we flip it into 2/1 to the 1st power. -2 times 2 is -4. Then if I take that to the 0 power, let me change that because this is looking gross. Take it to the 0 power, that's -2 times 1. What's that? -2. Then if we change that, say, okay, what if we take it 1/2 to the 1st power? Well, that's just 1/2. 2 times 1/2, -2 times 1/2 is going to be -2/2, which is -1. Then, get rid of this, and a little of that. If I take to the 2nd power, that's going to be times 1/4. So this would be -2/4, which is -1/2. Okay, so -2, -8, bing, bing, bing. -1, -4, bing, bong. 0, -2 right there. 1, -1 right there. 2, -1/2 right there. Now, another bonus point if I plug in -3. This would be -2 times 1/2 to the, and let me change this up a little bit to make it pop, -3rd power. Well, the first thing you'd notice is that you have to flip that 2/1 to the 3rd power, and 2 to the 3rd power is going to be 8. So -2 times 8 is going to be -16. So you can get -16 right here, which fits, which is why I wanted to add that to my graph. And still never crosses the x-axis. All right, thank you, ladies and gentlemen. Finish all the other problems on your own.